Objective 9.4, Simplifying, Multiplying, and Dividing Rational Expressions. Today I'm using a new technology, and so I hope it will go smoothly, but I hope you will also forgive me if there's a few glitches along the way. But I'm trying to use my iPad with an application called Explain Everything for today's lesson. So let's get started. In this objective, we want to be able to simplify rational expressions, and then we also want to be able to multiply and divide rational expressions to get answers in simplified form. So let's talk a little bit about what we know first. Let's go back to fractions. If I ask you to simplify a fraction like 8/12, we know that we need to look for common factors and then divide those common factors out. And so sometimes you will see teachers show it this way, where they'll take each of the numbers and they'll actually write it out in prime factorization. So for example, 8 would be 2 times 2 times 2, and 12 would be 2 times 2 times 3. And so if you think of it this way, you can easily see that we have some common factors. Change my color here for a second. So I can take out a 2 here, and I can take out a 2 there, and then what I'm left with is simply the 2 over 3, and so 8/12 would simplify to 2/3. Now we most often do this by just dividing both the top and the bottom by a common factor like 4. But the 4 is coming from this idea of what common prime factors each of the numbers have that can be canceled out. So when we apply that to rational expressions, we're looking again for common factors that can be canceled out. So one of the first things we need to look at is, do we have numerators and denominators that are in factored form? If we don't, then our first step is that we have to get them into factored form. But if they're already in factored form, then we can just proceed as we did with fractions. So in our first example here, where we have 8x to the 5th y squared over 6x squared y cubed, this would actually be considered factored form because the 8, let me try to use the 8 right here, the x to the 5th here, and the y squared here are all being multiplied by each other. So that makes each of those things a factor. Same with the 6, the x squared, and the y cubed. Each of those things is a factor because they're all being multiplied together. So that means we can go ahead and just start canceling. And when you're canceling like this, I would recommend that you sort of cancel in pieces. And what I mean by that is, you've got a number piece right here, and then you have right there where your base is x's, and then you have these terms where your base is y. So sort of think of this as doing 3 different simplifications. Simplify the numbers, simplify your x's, simplify your y's. So when we simplify the numbers, if we look at 8 and 6, we should be able to tell that each of those can be divided by 2. So if I divide by 2, that's going to leave me with a 4 here, and dividing by 2 will leave me with a 3 there. So I'm going to have a 4 on top and a 3 on the bottom. Next, I'm going to take a look at my x's. Since this is x to the 5th over x squared, one of the ways that we can deal with this is to simply subtract our exponents. Remember, that's one of our properties, is I can take that 5 minus that 2 to come up with the simplified form for my x base. So 5 minus 2 is going to give me a positive 3. And since it's a positive exponent, that tells me it's going to go in the numerator. So x cubed will go in the numerator part of my answer. Now I can do the same thing with the y's. Take this 2 minus this 3. When I do that, I end up with a negative 1. And so the negative would be what the exponent would be if I went on the top up here. But I don't want negatives in my answer because that's not considered simplified. So I'm going to switch that by taking the y to the negative 1 that would be here and moving it down below by changing my negative 1 exponent to a positive 1 exponent. So my final answer here is going to be 4x cubed over 3y. That's the simplified form of this original rational expression. Excuse me. Now in the second example here, we have two quadratics in our numerator and our denominator. And as is, they are not in factored form. So that's the first thing we need to do. We need to rewrite these in factored form. So x squared minus 4x minus 12 factors to x minus 6 and x plus 2. X squared minus 4 factors to x plus 2 and x minus 2. Unless I have these factors in my numerators and denominators, I cannot cancel anything. I cannot back here cancel the x squares, for example, because these are not factors. These are terms in my numerator and my denominator. I cannot cancel terms. I can only cancel factors. Okay, so now that I have factored form, I look for common factors. And what I can see is that I have a common factor of x plus 2. So the x plus 2 here will cancel with the x plus 2 there. And now what I'm left with is simply x minus 6 over x minus 2. Again, no canceling of x's because those are terms, and no dividing out a 2 between the 6 and the 2 because those are also just terms. So x minus 6 over x minus 2 is what I want for a final answer. So what about multiplying rational expressions? Again, let's talk about fractions first. When we have been asked to multiply fractions in the past, we usually will look for common factors that can be canceled out going across. So like 2 and 6, or 7 and 11, or even within a fraction. As long as it's a common factor that's in one denominator and one numerator, then we're okay. We can cancel things out. So in this case, if I do some canceling here first, I can see that both 2 and 6 can be divided by 2. So 2 divided by 2 will leave me with 1, while 6 divided by 2 will leave me with a 3. There really isn't anything else that can be divided out. The 7 and 11 do not share any factors, nor do the 3 and 11. So now I'm ready to write my answer. So now when I multiply across, the 7 times 3 is going to give me a 21, and the 1 times 11 will simply give me 11. Now, it's perfectly fine if you want to just leave your answers in proper fraction form, or if you really feel motivated, you can go ahead and change this to a mixed number, which would be 1 and 10 11ths. But the mixed number is not necessary. Improper fraction form is just fine. All right, so again, moving into rational expressions, we want to use that same idea. We want to look for common factors in numerators and denominators that we might be able to factor out or cancel out before we actually do the multiplying. And so here again, in the first problem that we have, all of our factors here are already being multiplied. There's no factoring necessary because each of these pieces are already being multiplied together and are factors. So we can start canceling. One of the things I notice is that 5 and 10 can both be divided by 5, so that'll be a 1 and a 2. I also notice that 2 and 6 can both be divided by 2, so that'll leave me with a 1 and a 3. Doesn't really look like there's anything left to cancel in the numbers, so now I'm going to go to the x's. I have an x squared here and an x here. So that means I can cancel out one of my x's and be left with just an x right here. Okay. I also see that for the y's, I have a y here that will cancel nicely with a y there. And I have two y's here that will cancel with two of the y's in this y cubed. And so I'm just going to cancel out the 3 and leave this one y. That appears to be all of the canceling that I can do. And so now I'm going to start putting things together based on what's left. So what's left in my numerator, as I go across here, what's left is an x, a 3, and an x cubed. And so that's going to leave me with 3x to the 4th. In my denominator, I'm left with a y and a 2. And so that's going to leave me with 2y. And so this now is my simplified answer to the multiplication of these two rational expressions. Now, same thing applies with our next example, but again, I'm starting with expressions that are not in factored form. These numerators and denominators are all, 3 of the 4 are all in quadratic form, and therefore need to be factored. This one is fine. It's just 4 times x. It's already in factored form. But the other 3 need some work. So let's do that first. 4x minus 4x squared, that's an example of a greatest common factor that can be factored out, which is 4x. And what I would have left is 1 minus x. In my denominator, I have x squared plus 2x minus 3. That can be factored into x plus 3 and x minus 1. And then in my second rational expression, the x squared plus x minus 6 can be factored into x plus 3 and x minus 2. And then finally, the 4x in the denominator, which can just stay as is. So now we can start looking for some canceling. So the first one is obvious to me. That's the x plus 3. Those two can cancel out. And I have a nice 4x right there that can cancel out there and there. Now you may think at this point that that's the only thing that you can cancel out. But there actually is one more cancellation that can be done. And that has to do with our 1 minus x and our x minus 1. Although they are not exactly the same factor at the moment, they are very similar factors. They are the same terms being subtracted but in reverse orders. Anytime that happens, when you have a factor that are the same terms being subtracted but in reverse order, then you can take and, in a sense, factor out a -1 from one of them. And by doing that, what happens is the 1, when you divide it by -1, becomes -1. And the negative x, when you divide it by -1, becomes positive x. And when you do that then, you end up with a factor of x minus 1, which matches the x minus 1 you had below. And so now you can cancel. But that still leaves you now with a -1 that has to be incorporated in your answer. Okay? If you're not really sure about what I just said, go ahead and rewind the tape, look at that one more time. And if you still have questions, ask me about it in class. I'll try to explain it a little bit more there if you're still not sure. But now if we go and put all of this together to get our final answer, in my numerator, I'm left with this -1 and this x minus 2. So I'm going to have a -1 times x minus 2. And again, you don't necessarily need to distribute this or multiply it out. Leaving it in factored form is just fine. And in the bottom, you'll notice everything actually got canceled out, so I'm really just left with a 1. So you don't really even have to write that. You can just leave your answer as -1 times x minus 2. All right, now for some dividing. Again, let's think about fractions first. How do we divide fractions? Well, hopefully you remember that dividing fractions is really not division at all. Instead, we change our division into a multiplication problem by multiplying by the reciprocal of the second number. So if I change my 15 over 7 divided by 3 over 8 into 15 over 7 times 8 over 3, I can now work this problem to get the answer to this problem. Okay? And so now I can do the same thing because I'm now working with multiplication. I can cancel common factors and then do my multiplication to get an answer of 40 over 7. Okay? So the same thing with rational expressions. If you're going to divide rational expressions like this, your first step is going to be to change it to a multiplication by flipping your second rational expression. And what I like to do is combine that step with the factoring step if that's necessary. So it would look something like this. My first expression stays in the same order. So I still have the 5x on top because it already is a 5 times x. Those are already factors. And on the bottom, my 3x minus 12 is going to become 3 times x minus 4. And then I'm going to multiply instead of add, or divide, excuse me. And then in my second rational expression, I'm going to put this on top, but in factored form. So that's going to be x minus 4 times x minus 2. And then I'll put this on top, excuse me, this on the bottom, but again in factored form. So that's going to be an x times x minus 2. Now I'm right back to doing problems like we were doing on the previous screen. I look for common factors to cancel out and then multiply what's left. So I can cancel an x minus 4, I can cancel an x minus 2, and I can cancel an x. And so what's left here for my answer is simply 5 over 3. Okay? All right, so let's try a few on your own. Here's a little bit of guided practice for you. In the first case, you just want to simplify. So go ahead and take this rational expression, factor it if necessary, cancel the common factors, and simplify this as much as you can. pause the video for a moment if you need to while you work this out. All right, so here's what your answer should look like. You would want to factor your numerator first, and so that's going to be x minus 6 times x plus 1. Then you would factor your denominator, which will be an x minus 1 times x plus 1. And then you can cancel the x plus 1s that are common factors to end up with an answer of x minus 6 over x minus 1. Okay? Here's your next guided practice. Try to multiply these two examples of rational expressions. Again, pause the video for a moment if you need to, and come back when you're ready to work it out. All right, so in the first problem, since everything is already being multiplied and is therefore all factors, we can just do some canceling. So let me change my pen color here, and let's get started. So I can cancel a 6 out of both 6 and 18, which will leave me with 1 and 3. I can divide a 2 out of both 2 and 10, which will leave me 1 and 5. I can cancel out the 2x squareds that are right there in the same fraction. I can cancel out 2 of the y's right there, so that still leaves me with this y. And I can cancel out 2 of the y's right here, which will leave me with a y squared. Don't really see anything else that can be canceled there. So now for my final answer, across the top I'm left with 5x cubed y cubed, because I have this y right here times this y right here times this y squared that was left. And then across the bottom it looks like I'm just left with a 3. So 5x cubed y cubed over 3 would be your answer to the first problem. In the second problem, we need to start by factoring. So we can factor out a 2x in the first numerator, and that will leave us with 2 minus x. In the the first denominator, we can factor it to x minus 3 times x minus 2. In the second numerator, we can factor that to an x minus 1 times an x minus 3. And then the 2x is already factors. So now for our canceling, I can cancel out the 2x's. I can cancel out the x minus 3's. And then here's another case where we have same terms being subtracted, but in reverse order. And so I can factor out a negative 1, to turn this into x minus 2, which will then allow me to cancel out the x minus 2's. And so what I have left for my final answer is simply negative 1 times x minus 1, because everything in the denominator has been canceled out. All right, practice for you. This time of division, again, go ahead and pause the video for a moment if you need to. All right, so in this case, remember we're going to factor and flip all at the same time. So my first rational expression will keep the 3 on top, and my denominator is going to factor to 4 times x minus 2. And then I'm going to multiply by the reciprocal of my second. So that means I want the factors of x squared plus x minus 6 on top, which will be x plus 3 times x minus 2. And then the x squared plus 3x, those factors should go on the bottom, which will be x times x plus 3. Okay, and so now, because it's multiplication, I can just cancel the common factors. So x plus 3's can cancel, x minus 2's can cancel, and what I have left then for my answer is 3 over 4x. All right, so that will give you enough information to be able to work through the practice problems for practice 9.4. If you have any questions on any of these concepts that you've seen, please make sure that you ask them during class. And when you finish with objective 9.4, please make sure you show it to me so I can check it off your list. We'll see you next class.